Hello, and welcome to Architect of Sleep. Tonight, we are leaving the noisy world behind to travel to the silent, dark world of the deep ocean. It is a place of deep stillness, where the laws of our world bend, and life takes on strange and beautiful forms. Here, pressure is a physical presence, and light is a distant memory, or a living flame created in the dark. For now, just breathe. Let your eyes grow heavy, and allow your mind to soften. Our journey begins now. The ocean is not one single place, but many worlds layered on top of each other. Like the floors of a great dark building, each level has its own rules, its own light, and its own inhabitants. We begin our journey at the surface, in the world we know, but we will descend slowly through these layers of water into the quiet mystery below. Each layer is a step deeper into a realm of profound peace, a step further away from the waking world, a slow descent into a liquid dream. The first layer is called the sunlight zone, the epipelagic zone. This is the ocean as we imagine it, bright and full of familiar life. It stretches down about 200 meters, or 650 feet. Sunlight pours into this layer, warming the water and giving energy to tiny plants called phytoplankton. These tiny organisms form the base of the entire ocean food web, breathing life into the blue water. This is a world of motion and light, a busy, vibrant surface on a deep, quiet sea. The bright sunlit roof of a very deep house. These phytoplankton are the true lungs of our planet, even more so than the rainforests. Through photosynthesis, they absorb carbon dioxide and release oxygen. It is estimated that they produce more than half of the oxygen we breathe. Every other breath you take is a gift from these tiny drifting plants in the sunlit ocean, a silent, invisible contribution from a world we rarely see, a planet breathing through its sunlit waters. Within this ocean of plankton, there are countless forms. Some are called diatoms, tiny single-celled algae that build intricate shells for themselves out of silica, the same material as glass. Under a microscope, they look like tiny, ornate jewel boxes, each species with its own unique and perfect pattern. When they die, these glass houses sink, becoming part of the sediment on the ocean floor, a secret architecture made of glass and light. Other tiny plants are called coccolithophores. They surround themselves with microscopic plates of calcium carbonate, like tiny, overlapping shields. These plates are called coccoliths. When these organisms bloom in vast numbers, they can turn the surface of the ocean a milky turquoise color, a beautiful cloud visible even from space. They, too, contribute to the deep ocean floor when they sink. Chalk white clouds, drifting in a blue sea. As we sink deeper, we leave the sunlight zone behind and enter the twilight zone. This is the mesopelagic zone, a world of growing shadows and fading light. It begins where the sunlight starts to fail, from 200 meters down to about 1,000 meters. Here, the light is faint and blue, not enough for photosynthesis, not enough to truly see. It is a world of silhouettes and ghost, where creatures are dark-colored or silvery to blend in with the gloom. The pressure begins to build, a gentle squeeze that reminds us we're going deeper, a slow blue fade into mystery. The temperature also changes dramatically here. We cross a boundary called the thermocline. where the warm, mixed surface water gives way to the deep, uniformly cold water. This change can be sudden, a sharp drop in temperature over just a few meters. It is a thermal cliff, an invisible wall that separates the upper ocean from the vast, cold world below. This layer acts as a barrier, trapping nutrients and organisms. A cold, invisible floor in the middle of the ocean. The water in this zone is not still. It is a place of great movement, though it is hidden from our eyes. Here, vast internal waves move slowly along the boundaries of water with different temperatures. These waves can be hundreds of feet high, giants moving in slow motion through the gloom. They mix the water and stir up nutrients, creating invisible currents and eddies that the inhabitants of the Twilight Zone must navigate. A secret tide flowing between the layers of the deep. The creatures here are adapted to the dim light. Many have very large, sensitive, tube-shaped eyes that point upwards. They are built to catch the faintest glimmer of light from above, to see the silhouettes of prey swimming against the pale blue ceiling of their world. Their eyes are not for seeing detail, but for detecting shadows, for sensing movement in a world of ghosts. Eyes like telescopes, pointed toward a disappearing sun. Now, we cross a threshold into true darkness, the Midnight Zone. This is the bathypelagic zone, and it is a world of eternal night. From 1,000 meters down to 4,000 meters, there is no sunlight at all. Not a single photon from the sun reaches this deep. The only light here is the light that living things create for themselves. The weight of the water above is immense, a crushing pressure that shapes everything that lives here. The water is cold, near freezing, and it is still. This is the beginning of the true deep, a vast black and silent kingdom, a realm where the only stars are the creatures that swim by. The sheer volume of this zone is hard to comprehend. The Midnight Zone is the largest single ecosystem on Earth, bigger than all of the forests and deserts on land combined. It is a world of immense, empty space, where encounters are rare and life must be patient. The average distance between two animals in this zone can be very large, making the search for food or a mate a monumental task. A vast, dark cathedral, mostly empty. Deeper still, we sink into the abyss. This is the Abyssopelagic Zone, a name that comes from a Greek word meaning bottomless. It stretches from 4,000 meters down to 6,000 meters, from 13,000 to 20,000 feet. The darkness is absolute, the cold is constant, and the pressure is extreme. It is hard to imagine life here, yet it persists. This is a world of scavengers, of slow-moving creatures adapted to a life of scarcity and immense force. The floor of the abyss is a vast flat plain of mud, covering much of our planet's surface in a thick, cold blanket, a silent, empty plain, under miles of water. The floor of the abyss is not entirely flat. It is dotted with small hills, called abyssal hills. These are the most common landform on the entire planet, yet they are hidden from our view. It is also scattered with strange, metallic lumps called manganese nodules. They grow incredibly slowly, adding a layer only a few atoms thick every year. They are like potatoes made of metal, growing over millions of years in the crushing dark. A strange metal garden on the floor of the world. Beyond the abyss, there are even deeper places. These are the Hadal zones, the trenches. The Hadal pelagic zone is found in the deep cracks and canyons of the seafloor, from 6,000 meters down to the very bottom of the ocean. These are the most mysterious and least explored places on Earth. The pressure is over 1,000 times what it is at the surface, the equivalent of having 50 jumbo jets stacked on top of you. And yet, even here, in the deepest, darkest, most pressurized parts of our world, there is life, a secret world, hidden in the planet's deepest scars. These trenches are formed by a process called subduction. This is where one of the Earth's great tectonic plates slides beneath another, bending downwards and plunging into the mantle. The trenches are the deep folds in the planet's crust created by this immense geological process. They are geologically active places, with earthquakes and volcanoes, a world of destruction and creation happening in extreme slow motion. The planet swallowing its own skin in the deepest dark. In this deep dark world, there is a constant gentle rain. It is not water, but something called marine snow. These are tiny particles of organic material, dead plants and animals, waste pellets, and dust that slowly drift down from the sunlit waters above. For the creatures of the deep, this marine snow is their primary source of food. It is a slow, steady blizzard that feeds the abyss, a constant connection to the bright world here, far above. Each flake is a tiny package of energy, a gift from the sun, falling for weeks to reach the bottom. A soft, endless snowfall in a world without winter. This snowfall is not just food. It is part of a great biological pump. As these particles sink, they carry carbon from the surface into the deep ocean. This process is a vital part of how the ocean regulates Earth's climate, by taking carbon out of the atmosphere and storing it in the deep for centuries. The slow drift of this organic dust is a quiet but powerful force, shaping the air we breathe, a gentle rain that buries the carbon of the world. The particles of marine snow are not lonely travelers. They are often clumped together by a sticky mucus secreted by bacteria and plankton. This process, called flocculation, makes the particles larger and heavier, causing them to sink faster. These larger clumps, sometimes called marine aggregates, deliver food to the deep more efficiently. They are the express elevators for nutrients, falling through the dark water. Tiny specks of life clinging together on their long journey down. The pressure in the deep sea is one of its defining features. It is a force that is hard to comprehend. At the bottom of the Mariana Trench, the pressure is over 16,000 pounds per square inch. At the surface, we experience about 15 pounds per square inch of air pressure. The deep sea is a world of immense, crushing weight. This pressure affects everything: the chemistry of the water, the geology of the seafloor, and the very bodies of the creatures that live there. It is a constant, powerful presence, a heavy, quiet blanket over the bottom of the world, the weight of an entire ocean, resting in the dark. This pressure even changes the way water behaves. It compresses the water molecules, making the water slightly denser. It also changes the speed at which sound travels and alters the rates of chemical reactions. Life in the deep has not only adapted to the physical force, but to a world where the fundamental rules of chemistry are subtly different. It is a world remade by weight, a force that bends the rules of biology and chemistry. A human body could not survive this pressure. Without the protection of a special submersible, the pressure would instantly crush us. The air spaces in our bodies, our lungs, our sinuses, would collapse under the immense force. The water would be forced into every cell, a swift and total end. It is a humbling reminder that this environment is not our own. We are visitors here, fragile guests in a world of extreme forces, a world that belongs to the creatures adapted to its powerful embrace, a gentle but absolute barrier between our world and the deep. So, how do creatures survive this crushing weight? Deep-sea animals are made mostly of water, which is very difficult to compress. They do not have air-filled spaces, like lungs or swim bladders that would collapse. Their bodies exist in equilibrium with the pressure outside. The immense pressure inside their cells perfectly balances the immense pressure of the water around them. To them, this pressure is normal. It is the very condition of their existence. They would not survive in our low-pressure world. A perfect balance between the creature and the deep. To achieve this balance, deep-sea life has evolved special molecules inside its cells. These molecules are called piezolites, from the Greek word for pressure. These small organic molecules help to stabilize proteins and cell membranes, preventing them from being crushed or distorted by the extreme pressure. One of these molecules is TMAO, trimethylamine N-oxide. It is what gives saltwater fish their slightly fishy smell, and it is essential for life in the deep, a tiny molecule that holds a body together against the weight of the world. The amount of TMAO in a fish's cells increases with depth. Scientists can tell how deep a fish lives just by measuring the concentration of this molecule in its tissues. It is a chemical fingerprint of pressure, a molecular record of the weight of water it has endured. This molecule works by helping proteins hold their proper shape, preventing the pressure from unfolding them and making them useless. A chemical shield against the crushing force of the deep. The deep ocean is also a place of profound and constant cold. Below the twilight zone, the temperature of the water hovers just a few degrees above freezing, typically between 0 and 3 degrees Celsius. This cold is stable. It does not change with seasons or time of day. It is a deep, penetrating chill that slows everything down. The creatures that live here have adapted to this eternal winter. Their bodies have special fats and enzymes that work at low temperatures, allowing them to function in the frigid darkness. A world held in a state of suspended cold animation. These special fats are important for keeping cell membranes fluid. In the intense cold, normal fats would become stiff and waxy, like butter in a refrigerator. This would stop the cells from working. Deep-sea creatures have a higher proportion of unsaturated fats in their membranes, which remain flexible and fluid even at near freezing temperatures. It is a simple chemical trick that makes life possible in the deep freeze. A body that stays soft in the heart of the cold. Some fish in the deep cold waters have also developed their own form of antifreeze. They produce special proteins in their blood, called antifreeze glycoproteins. These proteins circulate through the body and bind to any tiny ice crystals that begin to form, preventing them from growing larger. This effectively lowers the freezing point of their body fluids, allowing them to survive in water that is technically below the freezing point of their own blood. A body that refuses to freeze with a secret, natural antifreeze. You might wonder why the deep ocean does not freeze solid. The freezing point of water is 0 degrees Celsius, and the water in the deep is often that cold, or even slightly colder. The reason it remains liquid is because of two things: salt and pressure. The salt in the seawater lowers its freezing point, and the immense pressure makes it even harder for the water molecules to arrange themselves into the crystal structure of ice. So the water remains a fluid, a supercooled liquid, held in its state by the weight and salt of the sea, ice that is not allowed to form, kept liquid by the deep. In the complete absence of sunlight, the deep sea has created its own light. This is bioluminescence, the production of light by living organisms. It is a cold light, created by a chemical reaction that produces very little heat. It is the dominant language of the deep ocean, a silent, flickering conversation in the dark. Many, perhaps most, of the creatures in the deep can produce their own light. They glow and flash with blues and greens, turning the darkness into a secret, living constellation, a universe of tiny living stars in an ocean of night. The chemistry of this living light is simple and elegant. It involves a molecule called luciferin, which is the fuel, and an enzyme called luciferase, which is the spark. When the luciferase acts on the luciferin in the presence of oxygen, light is produced. Different species have evolved slightly different types of luciferin and luciferase, which is why bioluminescence can come in different colors and intensities. A simple chemical recipe for making starlight. This living light serves many purposes. It is a complex language of survival. Some creatures use their light to communicate with each other, to find mates in the vast darkness. A specific pattern of flashes can be a signal, a name, or a warning sent across the black water. It is a way of saying I am here, in a world where sight is otherwise impossible. These silent, glowing messages create a hidden network of connection, a community bound by light, a secret code written in flashes of blue. For other creatures, bioluminescence is a form of camouflage. This seems strange. How can light help you hide in the dark? It is a strategy called counter-illumination. A creature in the twilight zone, when seen from below, would create a dark silhouette against the faint light filtering down from above. To hide this silhouette, many fish and squid have light-producing organs on their bellies. They produce a gentle blue glow that perfectly matches the faint light from above, making them effectively invisible to predators hunting from below, using light to become a part of the darkness. The hatchetfish is a master of this technique. It has a thin, silvery body shaped like the blade of a hatchet. Its belly is lined with light-producing organs called photophores. It can precisely control the brightness of these lights, adjusting them to perfectly match the intensity of the light from above. It is a living stealth technology, a creature that can erase its own shadow, a silver coin that vanishes into the blue gloom. Light is also a weapon and a trap. Many predators in the deep use bioluminescence to attract their prey. The most famous example is the anglerfish. which has a long filament growing from its head with a glowing lure at the end. In the absolute darkness, this single point of light is irresistible to smaller fish and crustaceans. They swim towards the curious glow, only to be snatched by the huge waiting mouth of the anglerfish just inches away. It is a deadly and beautiful deception, a tiny false star leading to a sudden end, a fatal curiosity sparked by a living flame. But some creatures have taken this light-based warfare a step further. In the world of blue and green bioluminescence, one predator has a secret weapon. This is the deep-sea dragonfish. Like many creatures, it can produce blue light for communication, but it can also produce red light from a special organ near its eye. Most deep-sea animals cannot see red light, so the dragonfish can use its red bioluminescence like a secret sniper scope. It illuminates its prey, which remains completely unaware that it is being watched just before it strikes. A secret red torch in a world of blue shadows. The dragonfish's ability to both produce and see red light is a rare and powerful advantage. It is like having a secret channel of communication, a wavelength of light that no one else can perceive. It gives the dragonfish a private view of its world, allowing it to hunt with ruthless efficiency in the dark. It is a predator that has weaponized a color, a killer with a secret vision, in a land of the blind. Another use for light is defense, a sudden blinding flash to startle a predator. This is common in deep-sea shrimp. When threatened, they can spew a cloud of bioluminescent chemicals from their mouths. The bright cloud of glowing liquid hangs in the water, confusing the predator for a few crucial seconds, while the shrimp jets away into the darkness. It is like a firework, used as a smokescreen, a puff of light to cover a quick retreat. Some jellyfish and comb jellies have a similar defense. When they are disturbed, they can create a rippling, cascading display of light that travels across their bodies. This beautiful, startling display is called a burglar alarm. It is not meant to blind the attacker, but to attract the attention of a larger predator. The flash of light might draw in a bigger fish. That will eat the creature that is attacking the jellyfish. A beautiful alarm that calls a bigger monster from the dark. Let us look closer at the anglerfish, a true icon of the deep. It is a creature of nightmare and wonder. The female anglerfish is a round, strange-looking fish with a massive mouth filled with long, sharp, inward-pointing teeth. Once prey is caught in this mouth, there is no escape. She lives a slow, patient life, floating in the darkness using almost no energy. She simply waits, dangling her glowing lure, letting the food come to her. It is a life of perfect, patient efficiency, adapted to a world where meals are rare, a hungry darkness with a single shining tear. The light in the anglerfish's lure is not produced by the fish itself. The lure is filled with symbiotic, bioluminescent bacteria. The fish provides the bacteria with a safe home and nutrients, and in return, the bacteria provide the constant, steady glow that the fish needs to hunt. It is a partnership between a complex animal and a simple microbe, working together to survive in the dark. A tiny lantern, lit by 1 billion captive stars. The female anglerfish is the hunter, a formidable presence in the deep. The male anglerfish is a very different creature. He is tiny, often hundreds of times smaller than the female. His only purpose in life is to find a female. He has large eyes to spot the faint glow of her lure, and a highly developed sense of smell to track her pheromones through the water. He does not even have a functioning digestive system for long. His entire being is a tool for finding a mate in the vast empty dark. A tiny seeker on a quest for a giant. When the tiny male anglerfish finally finds a female, something extraordinary happens. He bites into her side and holds on. His body then begins to physically fuse with hers. His skin, his tissues, his blood vessels all merge with her body until he becomes a permanent part of her. He loses his eyes, his fins, and his internal organs, becoming little more than a pair of testes attached to her body, providing sperm whenever she is ready to reproduce. It is the ultimate commitment, a complete surrender of self in the lonely dark. Two beings becoming one in the abyss. Another strange inhabitant of the deep is the vampire squid. Its scientific name is Vampiroteuthis infernalis, which means the vampire squid from hell. But this creature is not a bloodsucker, and it is not a true squid. It is in a unique order of its own, a living fossil that has changed little in millions of years. It has a dark velvety cloak of webbing connecting its 8 arms, and large beautiful eyes that can be red or blue. It is a gentle, passive creature, a survivor from another time, a ghost from an ancient ocean, still drifting in the dark. The vampire squid does not hunt live prey. Instead, it is a detritivore, a scavenger of the deep. It has 2 long, retractable filaments that it can extend far out into the water. These filaments are covered in tiny, sticky hairs. The squid lets them drift in the current, collecting particles of marine snow. Then it reels the filaments in and scrapes the collected food off with its arms and into its mouth. It is a delicate and patient way of feeding, a spider in the dark, spinning a web to catch dust. When the vampire squid is threatened, it performs a unique defensive maneuver. It pulls its webbed arms up and over its body, turning itself completely inside out. This posture is called the pineapple defense. It exposes the underside of its arms, which are covered in spiky projections called cirri. This makes it look larger and more threatening. At the same time, it can eject a cloud of sticky, bioluminescent mucus from its arm tips, a sparkling cloud that can confuse a predator for precious seconds while the squid escapes into the darkness, a cloak of stars for a quick escape. In the midnight zone, mouths are often enormous. The gulper eel is a perfect example. This strange fish is mostly mouth and stomach. Its jaws are loosely hinged and can open incredibly wide, allowing it to swallow prey much larger than itself. The rest of its body is a long, thin whip-like tail that sometimes has a glowing tip, perhaps to lure prey. It swims slowly through the water, a giant gaping mouth searching for a rare meal. In a world of scarcity, you must be ready for any opportunity. No matter the size, a swimming mouth, waiting for a miracle. The gulper eel is also known as the pelican eel. Its pouch-like lower jaw is reminiscent of a pelican's bill. When it opens its mouth, this pouch inflates with water, making its head look enormous. This might be a threat display to scare off other predators. Or it could simply be the mechanism for gulping down a large volume of water in the hope of catching something small inside, a living net cast in the dark water. Another fish takes this strategy to its extreme. It is called the black swallower. This small, unassuming fish has a stomach that can stretch to an incredible degree. It is capable of swallowing prey that is 10 times its own mass and twice its own length. Scientists have found them dead at the surface, having swallowed a fish so large that the decomposition gases lifted the swallower all the way up from the deep. Eyes bigger than its belly, and a belly bigger than its body. Teeth can also be extreme in the deep. The fangtooth fish has the largest teeth of any fish in the ocean, relative to its body size. Its teeth are so long that it cannot close its mouth completely. The lower fangs slide into special sockets in its brain case to avoid impaling its own brain. Despite its ferocious appearance, the fangtooth is quite small, only about 6 inches long. It is a powerful hunter in its dark world, a tiny monster with an outsized bite, a reminder that survival in the deep requires powerful tools, a small body with a very big bite. There is a creature in the deep that has survived for hundreds of millions of years, almost unchanged. It is the hagfish, a jawless, eel-like animal. It has no true spine, but a skull made of cartilage. When threatened, it has a remarkable defense. It releases a thick, sticky slime from pores along its body, which instantly clogs the gills of any predator that tries to bite it. A single hagfish can turn a bucket of water into a bucket of goo in seconds, a living fossil that defends itself with a cloud of slime. The hagfish is also a scavenger. It has a keen sense of smell and can detect a dead or dying animal from a great distance. It enters the carcass through any available opening and eats it from the inside out. It can also tie its own body into a knot and use the knot to gain leverage while tearing off flesh. It is a strange but highly successful creature, a master of slime and a cleaner of the dead. Legends of sea monsters often speak of the kraken, a giant squid that could pull ships to the bottom of the sea. The giant squid is real, though it does not attack ships. It is one of the largest invertebrates on Earth, a sleek, powerful hunter of the deep. For centuries, we only knew of them from carcasses washed ashore, or from the sucker marks they left on the skin of sperm whales, their only known predator. Only recently have we managed to film a living giant squid in its natural deep-sea home, a legend made real, swimming in the secret dark. The eye of the giant squid is the largest eye of any known animal, on land or in the sea. It can be as large as a dinner plate or a human head. In the faint blue light of the twilight zone, or the bioluminescent flashes of the midnight zone, a huge eye is a huge advantage. It can gather the maximum amount of light, allowing the squid to spot the faint silhouette of prey, or the approaching shadow of a sperm whale. It is an eye built for seeing ghosts, for capturing the faintest whispers of light in a dark world. A giant living lens, staring into the abyss. The giant squid has a brain shaped like a donut. Its esophagus, the tube that carries food to its stomach, runs directly through the center of this donut-shaped brain. This means that everything the squid eats must be small enough to pass through the hole in its brain. It must shred its prey into tiny pieces with its sharp beak before swallowing. A brilliant mind with a very narrow passage. And yet, there is another squid that is even larger. The colossal squid is not as long as the giant squid, but it is much heavier and more robust. It is the largest invertebrate on the planet by mass. Instead of just suckers, its tentacles are armed with sharp, swiveling hooks, making it an even more formidable predator. It lives in the cold, deep waters around Antarctica, a true monster of the Southern Ocean. We know even less about the colossal squid than the giant squid. It is a greater mystery, a heavier shadow in the deep, a king of the depths, armed with hooks and darkness. Some of the most beautiful creatures in the deep are not single animals, but colonies. Siphonophores are related to jellyfish, but they are made up of thousands of individual, specialized organisms, all joined together. Some individuals are for swimming, some for catching prey, some for digestion, and some for reproduction. They all work together, forming a single, long, string-like superorganism that can be many meters long. 1,000 tiny bodies, working as one. The most famous siphonophore is the Portuguese man-o'-war, which lives at the surface. But in the deep, their relatives drift like long, ghostly nets. The species Praia dubia can reach lengths of over 40 meters, or 130 feet, making it one of the longest animals in the world. It is a fragile, nearly transparent line of life, pulsing with faint bioluminescence as it drifts through the black water. A living fishing line, longer than a blue whale. Each part of the siphonophore colony is called a zooid. These zooids are so specialized that they cannot survive on their own. They are like the organs of a single body, each with its own job. This level of cooperation makes the siphonophore one of the most complex and successful predators of the midwater, a drifting city of specialized workers. A single will, shared by 1,000 mouths. Not all deep-sea creatures are monstrous. The Dumbo octopus is a small, charming creature that lives on the abyssal plains. It gets its name from the 2 large ear-like fins on the side of its head, which it flaps gently to swim, like the Disney character flying. It drifts gracefully just above the seafloor, searching for small crustaceans and worms in the mud. It is a soft, gentle presence in a hard, pressurized world. A reminder that the deep sea has moments of quiet beauty and grace. A tiny, flying elephant in a world without sky. Unlike most octopuses, the Dumbo octopus does not have an ink sac. In the total darkness of the abyss, a cloud of black ink would be a useless defense. Instead, it relies on its gelatinous body to be unappetizing, and its ability to jet away quickly to escape danger. It also swallows its prey whole, another adaptation to a world where there is no time to waste. A gentle ghost with no need for ink. Many people have seen the picture of the blobfish, a gelatinous, sad-looking pink creature. But that is not what it looks like in its home. At the surface, its body is destroyed by the lack of pressure. In its natural habitat, thousands of feet down, the pressure of the water supports its body. It looks like a more normal, if slightly grumpy, fish. Its body is made of a gelatinous mass with a density just slightly less than water, allowing it to float effortlessly above the seafloor, waiting for food to drift by. A creature shaped by pressure, a body made of water and waiting. The tripod fish has a remarkable way of living. It is a long, thin fish that rests on the bottom of the abyssal plain. It uses 3 very long stilt-like fins, 2 from its pelvis and 1 from its tail, to stand on the soft mud. It stands perfectly still, facing into the gentle current, waiting for small shrimp or crustaceans to drift into its waiting mouth. Its eyes are very small and probably useless. It senses its prey by feeling the vibrations in the water with its long pectoral fins, which it holds out in front of it like antennae. A silent fisherman, standing on stilts in the dark. This fish is a hermaphrodite, having both male and female reproductive organs. This is a common strategy in the deep sea, where finding a mate is difficult. If a tripod fish meets another tripod fish, they can mate regardless of their sex. This doubles the chances of reproduction in a vast and empty world. A lonely life with a practical solution. Life in the deep is slow because energy is scarce. Most deep-sea creatures have a very slow metabolism. They move slowly, they grow slowly, and they live for a very long time. A slow metabolism is a key adaptation for surviving in a world where your next meal might be weeks or months away. Every movement is careful and deliberate. Every calorie is conserved. It is a life lived in slow motion, a patient existence in a patient world. The slow heartbeat of the abyss. This slow pace of life can lead to incredible longevity. The Greenland shark, which can live in the deep, cold waters of the North Atlantic, is the longest living vertebrate on Earth. Scientists have estimated that these sharks can live for up to 400 years, or even longer. They do not reach sexual maturity until they are over 100 years old. They are ancient, slow-moving giants, silent witnesses to centuries of change in the world above, while their own world remains constant and cold, a life that spans centuries, in the slow, cold dark. Even corals in the deep grow to immense ages. Unlike their tropical, sun-loving cousins, deep-sea corals live in total darkness and cold. They grow incredibly slowly, sometimes only a few micrometers per year. A large deep-sea coral colony, looking like a complex branching tree, can be thousands of years old. They are ancient animal forests, providing habitat for countless other species on seamounts and canyon walls. A forest of stone that grows for 1,000 years. A strange phenomenon in the deep is called deep-sea gigantism. It is the tendency for some species of invertebrates and other deep-sea animals to be much, much larger than their relatives in shallower waters. The reasons are not fully understood, but may be related to the cold temperature, the high pressure, or the scarcity of food. It is as if the deep, in its vast emptiness, allows things to grow to enormous sizes over their long, slow lives. Small things becoming giants in the vast, dark space. A perfect example of this is the giant isopod. You may know isopods as the small grey woodlice or pillbugs you find in your garden. In the deep sea, they can grow to be over a foot long. They are scavengers, crawling along the abyssal floor, feeding on whale falls or any other dead thing that sinks from above. They can go for years without eating, waiting patiently for a large meal to arrive. They are like ancient armored robots, cleaning the floor of the deep ocean. A garden bug, grown to the size of a cat. The largest of all arthropods, creatures with exoskeletons and jointed legs, lives in the deep waters off the coast of Japan. This is the Japanese spider crab. Its body is large, but its legs are incredibly long. The leg span of a large male can reach up to 12 feet, or nearly 4 meters, from claw to claw. They are like giant, slow-moving spiders, stalking the sea floor. They are another example of deep-sea gigantism, of life expanding to fill the vast, three-dimensional space of the deep. A spider the size of a small car, walking slowly in the quiet. The deep ocean is often called silent, but this is not true. It is filled with sounds. They are just not the sounds we are used to. Sound travels much farther and faster in water than in air. The deep is a soundscape of clicks, moans, and pulses. For years, submarine crews in the Southern Ocean detected a strange, repeating sound, like a duck quacking. They called it the bioduck. It was a mystery for decades, until it was finally identified as the call of the Antarctic minke whale, a strange quacking from a giant of the deep. In 1997, underwater microphones recorded an incredibly powerful, ultra-low frequency sound in the Pacific Ocean. It was nicknamed the bloop. It was louder than any known animal sound, and it was heard by sensors over 5,000 kilometers apart. For years, people speculated it was a giant unknown sea monster. The mystery was finally solved. The sound was consistent with the noise of a large iceberg cracking and breaking away from a glacier in Antarctica. It was the sound of ice, not a monster, the deep sigh of a continent of ice. The way sound travels in water makes it the primary sense for many large marine animals. In the dark, or over vast distances, sight is of little use. But sound can travel for hundreds, even thousands of miles. The deep ocean has a special layer called the SOFAR channel, or the deep sound channel. Sound waves that enter this channel can travel across entire oceans with very little loss of energy. It is a natural waveguide, a highway for sound, a river of sound flowing through the silent water. Whales are the masters of this soundscape. Blue whales and fin whales produce very low-frequency calls that are incredibly loud, louder than a jet engine. These powerful sounds can travel for thousands of miles through the deep sound channel. This allows whales to communicate with each other across entire ocean basins. A whale off the coast of California could potentially hear the call of a whale in Japan. It is a planet-spanning conversation, a slow, deep song that connects a global community. A lonely song that is heard an ocean away. But sight and sound are not the only senses in the deep. In the dark water, the sense of smell, or chemoreception, is vital. Currents carry chemical trails for miles, signals of food, predators, or potential mates. Many deep-sea fish have huge nostrils and large olfactory bulbs in their brains. They are built to navigate a world of scents. A single molecule can be a message, a hint of a distant meal drifting on a slow current, following a ghost of a scent through the dark. Another sense is touch, but a kind of long-distance touch. Most fish have a lateral line system, a series of pores and canals along their sides that can detect tiny changes in water pressure and movement. In the total darkness of the deep sea, this sense is highly refined. It allows a fish to feel the wake of a tiny shrimp swimming nearby, or the approaching pressure wave of a large predator. It is like having skin that can hear the water move. Feeling the shape of the darkness through the water's vibrations. Some deep-sea animals, like sharks, have an additional sense, electroreception. They have special organs called ampullae of Lorenzini, small pores on their snouts filled with a conductive gel. These organs can detect the incredibly faint electrical fields produced by the muscle contractions of other living things. This allows a shark to find prey that is completely hidden, buried in the mud or perfectly still in the dark. A sixth sense for feeling the spark of life. In the 1970s, scientists exploring the deep ocean floor made a discovery that changed our understanding of life on Earth. They found hydrothermal vents. These are like geysers on the ocean floor, spewing out superheated, mineral-rich water from beneath the Earth's crust. Around these vents, in the total darkness and crushing pressure, they found teeming ecosystems, oases of life where no life was thought possible. It was a discovery as important as finding life on another planet. A garden of life, growing around a black chimney. The search for these vents began with a theory. Scientists knew that the Earth's crust was being formed at mid-ocean ridges. They predicted that seawater must be seeping into the crust, getting heated by magma, and then rising back out. They went looking for these hot springs, and in 1977, near the Galapagos Islands, a submersible named Alvin descended into the darkness, and its lights landed on a site no one had ever seen before. A world of strange creatures clustered around shimmering, warm water, a theory confirmed by a journey into the dark. The most dramatic of these vents are called black smokers. They are tall, chimney-like structures, built up from minerals that precipitate out of the hot water. The water coming out of them can be over 400 degrees Celsius, hot enough to melt lead. It looks black because it is full of dark mineral particles, especially iron sulfide. This hot, toxic fluid, which would be deadly to most life, is the very foundation of the vent ecosystem. It is the source of all energy, a black smoke that gives life instead of taking it. There are also white smokers. These vents are generally not as hot as black smokers, and they release water that is rich in different minerals like barium, calcium, and silicon. These minerals are white, giving the smoke its color. White smokers tend to build smaller, more delicate chimney structures. Both black and white smokers create a chemical-rich environment, a special kind of fuel that life in the deep has learned to use in the absence of sunlight. A gentler chimney, breathing white mist into the water. The life around these vents is not powered by the sun. It is powered by chemosynthesis. This is a process where organisms, mostly bacteria, use the chemical energy from the vent fluid, particularly hydrogen sulfide, to create food. It is a completely different way of making a living, a separate tree of life that is not dependent on light. These bacteria form the base of the vent food web, just as phytoplankton do at the surface. They are the sons of the deep, creating energy from the Earth's inner fire. A life built on poison in a world without sun. The most iconic creatures of the hydrothermal vents are the giant tube worms. These strange animals can grow up to 8 feet tall. They have no mouth, no stomach, and no gut. They look like giant white plastic tubes with a bright red feathery plume at the top. They live in dense thickets around the vents, swaying gently in the flow of warm water. They are a symbol of this strange alien world, a forest of impossible creatures, a lipstick red flower, blooming in the eternal night. The secret to the tube worm's survival is inside its body. Its trunk is packed with a special organ filled with symbiotic bacteria. The red plume at the top of the worm acts like a gill, absorbing hydrogen sulfide, oxygen, and carbon dioxide from the water. The worm's blood then transports these chemicals to the bacteria. The bacteria use the chemicals to make food, and they share this food with the worm. The worm provides a safe home and raw materials. The bacteria provide the energy. It is a perfect partnership. A farmer and its crop, living as one being. One of the most incredible vent creatures is the Pompeii worm. It is a small, hairy-looking worm that lives in paper-like tubes right on the sides of black smoker chimneys. It is one of the most heat-tolerant animals on Earth. Its tail end can be sitting in water as hot as 80 degrees Celsius or 176 degrees Fahrenheit, while its head sticks out into the much cooler surrounding water. It is covered in a fleece of bacteria, which may act as insulation and also as a food source. A creature that lives with its feet in boiling water. Another fascinating vent dweller is the Yeti crab. This furry-looking crab was discovered in the South Pacific. Its arms are covered in long, silky hairs, which are actually filaments that host colonies of bacteria. The crab is often seen waving its arms back and forth in the vent fluid. It is thought that it may be farming the bacteria on its own claws, providing them with the chemicals they need to grow, and then eating them. It is a farmer in the deep, tending to its own personal garden, a furry crab, dancing to feed its children. Hydrothermal vents are not the only places where chemosynthesis happens. There are also cold seeps. These are areas on the ocean floor where hydrogen sulfide, methane, and other hydrocarbon-rich fluids seep out at a slow, steady pace. The temperature of the fluid is the same as the surrounding seawater, but the chemicals still provide a source of energy for bacteria. These cold seeps support ecosystems that are similar to vent communities, with tube worms, clams, and mussels, all living a life independent of the sun. A slow, cold leak that nourishes a secret garden. At some cold seeps, something amazing can be found. The combination of high pressure, low temperature, and methane gas can create a substance called methane hydrate. It looks like white ice, but it is flammable. It is a frozen lattice of water molecules with methane gas trapped inside. On the seafloor, it is a stable solid, but if you bring it to the surface, it will fizz and melt, releasing the methane gas. It is often called fire ice, ice that can burn, a frozen gas at the bottom of the sea. These strange methane ice deposits support their own unique life. Tiny pinkish worms have been found living on the surface of the hydrates. These are ice worms. They burrow into the strange ice, and they appear to be grazing on the bacteria that grow there. Bacteria that feed on the methane. It is a bizarre and specialized ecosystem, a community living on and in a block of frozen flammable gas. A pink worm, living in a house of fire ice. In some parts of the deep ocean, there are underwater lakes. These are called brine pools. They form when water seeps through thick layers of salt on the seafloor, becoming incredibly salty, much saltier than the surrounding ocean. This super salty water is also much denser, so it sinks and pools in depressions on the ocean floor, forming a distinct lake with a clear shoreline. you can see the waves on the surface of the brine pool, where it meets the normal seawater. A lake within an ocean with its own strange shore. These brine pools are deadly to most marine life. The water in them is so salty and contains no oxygen that any fish or crab that accidentally swims into it is instantly pickled and preserved. The shorelines of these deadly lakes are often littered with the bodies of creatures that made a fatal mistake. But even here, on the very edge of the brine, life finds a way. Mussels thrive at the shoreline, feeding on bacteria that use the methane seeping from the pool. A deadly lake with a shoreline of life. The floor of the ocean is not all flat mud. It is a landscape as varied and dramatic as any on land. There are vast mountain ranges called mid-ocean ridges, and deep canyons called trenches. And scattered across the plains, there are underwater mountains called seamounts. These are volcanoes that have risen from the seafloor but have not reached the surface of the water. There are tens of thousands of them in the world's oceans, most of them completely unexplored, a hidden mountain that has never seen the sun. Seamounts are islands of life in the deep ocean. They rise up from the abyssal plain, and their rocky slopes provide a hard surface for corals, sponges, and other filter feeders to attach to. The way the mountain deflects the deep ocean currents also brings a steady supply of nutrients and food particles. Because of this, seamounts are biodiversity hotspots, teeming with life. They are like busy, vertical cities rising from the quiet, empty plains of the abyss, an underwater city built on the slopes of a volcano. In some parts of the world, on the slopes of seamounts and continental shelves, there are vast reefs made not of coral, but of glass. These are glass sponge reefs. The sponges have skeletons made of silica, the same material as glass. These skeletons are incredibly intricate, and they fuse together over time to create huge, delicate reef structures. These reefs were thought to be extinct, until living ones were discovered off the coast of Canada in the 1980s. A reef made of glass, a fragile crystal palace in the deep. The skeletons of these glass sponges are remarkable. They are made of tiny, hair-like fibers of silica called spicules. These fibers are incredibly strong and flexible, and they can transmit light better than our own man-made fiber optic cables. Scientists are studying these natural fiber optics, hoping to learn how to create better telecommunication technologies. Nature has already perfected a technology we are just beginning to understand. A secret of light, hidden in a skeleton of glass. Between these mountains and trenches lies the abyssal plain. This is the vast, flat, sediment-covered floor of the deep ocean. It covers more than 50% of the Earth's surface. It is the largest single habitat on our planet. It seems empty and lifeless, a desert of cold mud. But it is home to a surprising number of creatures, most of them small, living in or on the sediment. It is a world of slow movement, patient waiting, and subtle traces in the mud. A vast, quiet desert at the bottom of the world. The mud of the abyssal plain is made of the skeletons of tiny marine organisms and fine clay particles that have settled over millions of years. This sediment is called ooze. It is incredibly fine and soft. It holds a record of the Earth's past climate, trapped in the layers of tiny fossils. Scientists can take core samples of this mud, and read the history of the oceans and the atmosphere, going back millions of years. A library of time written in dust and shells. The dominant life forms on these plains are often sea cucumbers. These are strange sausage-shaped relatives of starfish and sea urchins. They crawl slowly across the seafloor, ingesting the mud, digesting the organic matter from the marine snow, and excreting the clean sediment behind them. They are the earthworms of the deep sea, constantly tilling and processing the abyssal ooze. They are slow, methodical, and essential to the health of the deep-sea floor. The slow, quiet gardeners of the abyss. Some of these sea cucumbers are truly strange. The species Enypniastes eximia, also known as the headless chicken monster, is a swimming sea cucumber. It has a gelatinous, translucent body, and it can launch itself from the seafloor and swim for hundreds of meters, using its webbed veil to propel itself through the water. It is a bizarre, beautiful sight, a crimson ghost drifting through the blackness, a swimming sausage flying through the water. When a great whale dies in the open ocean, its body sinks. This event, called a whale fall, creates a temporary but incredibly rich ecosystem on the abyssal floor. A single whale carcass can provide as much food as thousands of years of normal marine snow. It is a massive feast, a sudden explosion of life in the food-poor deep. The discovery of whale falls showed scientists how nutrients can be transferred to the deep in large, sudden packages, a gift from the surface, a mountain of food in the desert. The decomposition of a whale fall happens in stages and supports a succession of different communities. First come the mobile scavengers, like sleeper sharks, hagfish, and giant isopods. They can strip a whale of its flesh in a matter of months. Then come the enrichment opportunists, smaller creatures like worms and crustaceans that colonize the bones and the surrounding enriched sediment. This stage can last for years, a slow, unfolding feast that lasts for a decade. The final stage is the most remarkable. It is the sulfophilic stage, where bacteria begin to break down the lipids, the fats, inside the whale's bones. This process releases hydrogen sulfide, which is the same chemical that powers hydrothermal vents. This chemical energy then supports a whole community of chemosynthetic life, including mussels, clams, and strange worms. A whale skeleton can support this kind of community for 50 to 100 years, a skeleton that becomes an oasis, breathing life from death. One of the strangest creatures found on whale falls is a worm called Osedax, which means bone eater in Latin. These are sometimes called zombie worms. They have no mouth or stomach. The female worm secretes an acid that dissolves the bone, and she has a root-like system that grows into the bone marrow, absorbing the nutrients. The males are microscopic and live inside the female's body, their only job to produce sperm, a flower of flesh that blooms on a bone. The deepest part of the entire ocean is the Challenger Deep, located in the southern end of the Mariana Trench in the Western Pacific. It is a small slot-shaped valley on the floor of the trench. The bottom is nearly 11,000 meters, or almost 7 miles, below the surface. If you were to place Mount Everest into the trench at this point, its peak would still be covered by more than a mile of water. It is the most remote and inaccessible place on our planet, the lowest point on the surface of the Earth. The depth of the Challenger Deep is difficult to measure precisely, and even harder to imagine. It is 10,184 meters, or 36,037 feet. The journey down, even in a fast submersible, takes hours. The darkness is absolute long before you get there. The temperature is near freezing. It is a place of profound isolation, a tiny point of exploration in a vast unknown realm. It is the final frontier on our own planet, a place more alien than the surface of the moon, a journey to the bottom of the world. The pressure at the bottom of the Challenger Deep is over 100 times the pressure at sea level. It is the weight of the entire column of water, 7 miles high, pressing down. This immense force changes the very properties of water, making it denser. It is a physical force that defines this Hadal world, a constant crushing presence that has shaped the few organisms that can survive there, a pressure that could turn carbon into diamond. The first humans to visit the Challenger Deep were Jacques Picard and Don Walsh. In the submersible Trieste in 1960, their descent took almost 5 hours. They spent only 20 minutes on the bottom, their view obscured by the cloud of sediment they kicked up. But in that short time, they saw something that changed biology forever. They saw a flatfish, a type of sole, swimming by. It was proof that complex vertebrate life could exist and thrive under the most extreme pressure on the planet. A single flat fish that rewrote the rules of life. What else lives in the trenches? We are only just beginning to find out. Explorations have found strange, translucent snailfish, which seem to be the top predators of the Hadal zone. They have found giant amphipods, shrimp-like crustaceans that are much larger than their shallow water relatives. And there are vast mats of bacteria and single-celled organisms called foraminifera. It is not a barren world, but a specialized one, a community of survivors in the extreme, a small, tough community at the bottom of everything. In 2012, the filmmaker James Cameron made the first solo dive to the bottom of the Challenger Deep. His submersible was a marvel of engineering, designed to withstand the crushing pressure. He spent hours on the bottom, filming and collecting samples. He described it as a completely alien world, a desolate lunar landscape. His journey was a powerful reminder of how much there is still to explore, one person at the deepest point on Earth. It is a strange fact that we have better maps of the surface of Mars and the Moon than we do of our own planet's sea floor. More than 80% of the ocean floor remains unmapped, unobserved, and unexplored. We know the general shape of the bottom, but not the fine details. There are almost certainly huge mountain ranges, deep canyons, and countless seamounts that we have never seen. The age of discovery is not over. Its greatest chapter may lie beneath the waves, a world of hidden landscapes, waiting to be seen. Our knowledge of the deep began with one epic journey. Between 1872 and 1876, the HMS Challenger sailed around the world on a scientific expedition. It was the first voyage organized specifically to study the deep ocean. Using ropes and dredges, its scientists collected samples from all the world's oceans, discovering over 4,000 previously unknown species. It was the birth of modern oceanography, the first systematic look into the great dark unknown, a single ship that opened a new world. We map the ocean floor using sound, not light. A system called multi-beam sonar, mounted on the hull of a ship, sends out a fan-shaped pulse of sound waves. These sound waves travel to the bottom, bounce off the sea floor, and return to the ship. By measuring the time it takes for the sound to return and the angle it comes back at, computers can create a detailed, three-dimensional map of the bottom topography. It is like painting a picture, with echoes, seeing with sound through miles of dark water. To explore specific sites in the deep, we use submersibles. Most modern exploration is done with remotely operated vehicles, or ROVs. These are unmanned robotic submarines that are connected to a ship on the surface by a long tether or cable. The cable provides power and sends data. Pilots on the ship can fly the ROV in real time, using joysticks and watching video feeds from the ROV's cameras. It allows us to explore for hours or days at a time, without risking human lives. A robot explorer with human eyes a mile above. There are also autonomous underwater vehicles, or AUVs. These are also robotic submarines, but they have no tether. They are pre-programmed with a mission, and they navigate on their own, like an underwater drone. They can cover large areas of the seafloor, creating maps or collecting data. After their mission is complete, they return to the surface to be collected by a ship. They are our scouts, venturing alone into the unmapped dark, a robot mind, exploring on its own. Deep-sea exploration is incredibly challenging. The pressure is a constant threat. The darkness is absolute, and the cold is extreme. Seawater is corrosive and unforgiving to complex electronics. The distances are vast, and the weather on the surface can make it impossible to work. Every dive is a complex, expensive, and risky operation. It is why the deep sea still holds so many secrets. It does not give them up easily. A difficult journey to a fragile, hidden world. One of the most saddening discoveries of modern deep-sea exploration is the presence of our trash. Scientists have found plastic bags, beer cans, and other human debris in the deepest parts of the ocean, including the bottom of the Mariana Trench. The things we throw away can find their way to the most remote and pristine environments on Earth. It is a sobering reminder that our actions have consequences that reach far beyond the world we can see. Our footprint in the deepest dust. The deep ocean plays a critical role in regulating our planet's climate. It acts as a giant carbon sink. The ocean absorbs about a quarter of the carbon dioxide that humans release into the atmosphere. Much of this carbon eventually finds its way into the deep ocean through the sinking of cold, dense water at the poles and through the constant rain of marine snow. The deep sea is a vast reservoir, locking away carbon for hundreds or thousands of years. The deep, slow breath of the planet. The process of absorbing carbon dioxide is not without a cost. As CO2 dissolves in seawater, it forms carbonic acid. This is causing the ocean to become more acidic. This process, called ocean acidification, is a threat to many marine organisms, especially those that build shells or skeletons out of calcium carbonate, like corals, clams, and some plankton. It is a silent, invisible change that could have a profound impact on ocean life, a slow, souring tide that threatens the shell builders. The water in the deep ocean is not stagnant. It is moving in a slow, massive global current. This is often called the global conveyor belt, or the thermohaline circulation. It is driven by differences in temperature and salinity. In the North Atlantic, cold, salty water becomes very dense and sinks to the bottom. This deep water then flows south, around the globe, slowly warming and rising back to the surface in the Pacific and Indian Oceans. A great, slow river that circles the globe in darkness. This global conveyor belt is incredibly slow. A single molecule of water sinking in the North Atlantic might take 1,000 years to complete its journey through the deep ocean and return to the surface. This slow circulation means that the deep ocean is a very stable environment. Changes happen on the timescale of centuries or millennia. It also means that it is very slow to recover from any disturbance. A journey that takes 1,000 years through the cold and the dark. Because it is so isolated from the surface and the atmosphere, some parts of the deep ocean have very little oxygen. These areas are called oxygen minimum zones, or OMZs. They typically occur in the twilight zone, where bacteria decomposing the rain of marine snow use up all the available oxygen. These are difficult places to live, but some creatures have adapted with highly efficient gills and blood, or by living a very slow, low-energy life, a world holding its breath in the middle depths. Creatures that can tolerate these low oxygen zones have a unique advantage. Their predators often cannot follow them there. The OMZ can act as a refuge, a safe place to hide during the day. This is one of the reasons for a remarkable daily event in the ocean, the Great Vertical Migration. It is a daily journey from the deep to the surface, and back again, a journey into a world without air, to escape a hungry mouth. On sonar screens, oceanographers often see a false bottom that appears at night and disappears during the day. This is the deep scattering layer. It is not the seafloor, but a dense layer of living things, fish, squid, shrimp, and plankton, that are so numerous they reflect sound waves. This layer is the heart of the largest migration on our planet, happening every single night in every ocean. A false floor made of 1 billion tiny hearts. Every evening, as the sun sets, the creatures of the deep scattering layer begin a journey upwards. They swim hundreds or even thousands of feet from the dark twilight zone up to the rich surface waters. They go there to feed on the phytoplankton and smaller zooplankton under the cover of darkness. Then, as the sun rises, they make the long journey back down into the safety of the deep dark water to avoid being seen and eaten by predators. The greatest migration on Earth, happening every single night. This daily vertical migration is a massive movement of life. The total biomass of animals moving up and down each day is enormous. It is a vital process that transports huge amounts of carbon and nutrients from the surface into the deep ocean. It is the planet's largest and most regular movement of animals, a daily pulse that connects the world of light with the world of darkness, a living pump connecting the surface to the deep. In a world without light to hide in, another way to become invisible is to be transparent. Many creatures of the midwater have evolved bodies that are almost completely clear. They are living ghosts, made of gelatinous tissue that has the same refractive index as seawater. light passes right through them, making them incredibly difficult to see. They are a testament to the power of evolution to find creative solutions to the problem of survival. A body made of glass, in a world of shadows. The glass squid is a master of this transparency. Its body is a clear gelatinous sac, and you can see its internal organs, its digestive gland, and its gills right through its skin. It even has a clever trick for its eyes, which are not transparent. To hide the shadow of its eyes, it can orient them vertically, or use bioluminescent rings around them to break up their silhouette. It is a creature that has almost perfected the art of not being there at all. A ghost in the machine, a squid made of water. Perhaps the most amazing transparent creature is the barrel fish. It lives in the twilight zone. Its head is a completely transparent, fluid-filled dome. Inside this dome, you can see its eyes. They are large, green, tube-shaped eyes that can rotate. They usually point straight up to spot the silhouettes of prey against the faint light from above. When it sees something it wants to eat, it can rotate its eyes to point forward as it moves in to feed. A living cockpit with eyes that look through the ceiling. While some creatures are transparent, many others are a deep dark red or black. This is another form of camouflage. Red light from the sun is the first color to be absorbed by water. It does not penetrate into the deep. In a world that is only lit by faint blue light, a red object absorbs all of the blue light and reflects no light back. This means a red creature appears completely black and is therefore invisible, wearing red to become a shadow. The deep ocean is full of red-colored animals, especially shrimp and other crustaceans. To a predator's eye, in the ambient blue light of the twilight zone, they are simply gone. They blend into the blackness of the background. It is a simple but highly effective strategy. Of course, this camouflage is useless against a predator that brings its own light, like a submersible or a fish with a bioluminescent headlight, a cloak of invisibility that only works in the dark. The deep ocean is not just a passive recipient of the world's climate, it also helps to create it. The vast heat capacity of the ocean and the slow movement of deep currents act as a flywheel for the Earth's climate system. The ocean stores and transports enormous amounts of heat around the globe, influencing weather patterns and creating long-term climate cycles that can last for decades or centuries. The slow, deep engine of our planet's weather. The seafloor is geologically active. There are more active volcanoes under the ocean than there are on land. Most of these are located along the mid-ocean ridges, the seams of the Earth's tectonic plates. When these volcanoes erupt, they release huge amounts of heat and chemicals into the water. They also create new seafloor, new crust for our planet. The bottom of the ocean is a place of constant, but very slow, creation. The slow birth of new land, under a cold, dark sea. This process of seafloor spreading is how the continents move. New crust is formed at the mid-ocean ridges, and old crust is destroyed as it sinks back into the Earth's mantle at deep-sea trenches. The ocean floor is constantly being recycled, which is why the oldest oceanic crust is only about 200 million years old, while continents can be billions of years old. The ocean floor is young and always renewing itself in fire and water, a conveyor belt of rock, carrying the continents on its back. The sheer volume of the deep ocean is staggering. It contains about 99% of the living space on our planet. All the land, all the forests, all the shallow seas are just a tiny fraction of the available habitat on Earth. The vast majority of our world is deep, dark, cold water. We live on a thin, bright skin, on top of a huge, mysterious, and mostly unknown world. A planet of water, with a few small islands of rock. The average depth of the ocean is about 3,700 meters, or 12,100 feet. That is more than 2 miles deep. Most of the ocean floor, the abyssal plains, lies between 3,000 and 6,000 meters deep. This means that the majority of our planet's surface is a deep, dark, cold, high-pressure environment. The world we think of as normal is actually the exception. The deep sea is the rule. The true face of our planet is a dark and quiet one. Scientists divide deep-sea life into 2 main categories. There is pelagic life, which lives up in the water column, swimming or drifting in the vast open space. And there is benthic life, which lives on or in the seafloor itself. These are 2 very different ways of life. One in a 3-dimensional world with no landmarks, the other on a 2-dimensional surface of mud or rock. Both are shaped by the same darkness, pressure, and cold. The swimmers and the crawlers of the deep. In the vast, dark, and sparsely populated world of the deep sea, finding a mate is one of the greatest challenges. We have already seen the strange solution of the anglerfish. Other species have evolved to be hermaphrodites, possessing both male and female reproductive organs. If you meet another member of your species, you are guaranteed to be able to mate. It is a practical solution to the problem of loneliness, doubling your chances of success. A lonely life made a little less lonely. The cold, dark, low-oxygen environment of the deep sea is a perfect place for preservation. Shipwrecks that sink into the deep can remain remarkably intact for centuries, or even millennia. The wood-eating organisms of the surface cannot survive in the deep, and the cold slows down all chemical and biological decay. The deep sea is a museum, holding lost ships in a state of suspended animation, a silent museum at the bottom of the sea. A stunning example of this is the Black Sea. Below about 150 meters, the water in the Black Sea is anoxic. It has no oxygen. This is due to its unique geology. It is a deep basin with only a narrow connection to the rest of the world's oceans. In this anoxic water, shipwrecks are perfectly preserved. Expeditions have found ancient Greek and Roman trading vessels, sitting on the seafloor as if they sank yesterday, with their masts still standing and their cargo still in the hold. Ghost ships, waiting in a sea without air. The extreme pressure of the deep can create forms of matter that seem impossible. We know that pressure makes it hard for water to freeze into normal ice. But at very high pressures and specific temperatures, water can form other denser types of ice, known as Ice 3, Ice V, and Ice 6. These are not found naturally on Earth, but they may exist on the icy moons of Jupiter and Saturn, where oceans lie beneath thick crusts of ice. Strange ice, born from impossible pressure. The unique biochemistry of deep-sea organisms may hold a treasure trove of new discoveries for medicine. Because they live in such extreme environments, these creatures have evolved unique proteins and chemical compounds. Scientists are studying sponges corals, and bacteria from the deep sea, searching for new antibiotics, anti-cancer agents, and other drugs. The cure for a human disease might be waiting in the dark, inside a creature we have not even discovered yet. A pharmacy of secrets hidden in the abyss. The ecosystems of the deep sea are incredibly fragile. Because life there is so slow, recovery from damage is also incredibly slow. A deep-sea coral reef that is destroyed by a fishing trawl may take thousands of years to grow back. If it ever does, the tracks left in the mud by a submersible can remain visible for decades. It is a world that is easily wounded and very, very slow to heal. A fragile garden that remembers every scar. The slowness of the deep applies to everything. A deep-sea clam might live for 500 years. A manganese nodule, a lump of metal on the abyssal plane, grows at a rate of only a few millimeters per million years. It is a world that operates on a geological timescale, not a human one. Our brief, fast lives are a frantic flicker compared to the slow, patient existence of the deep. A world where a million years is just a moment. Some deep-sea creatures have developed a burglar alarm defense. If a small shrimp is attacked by a predator, it might release a bright flash of bioluminescent fluid. This does two things. It can startle the predator, causing it to release the shrimp. But more importantly, the bright flash can attract the attention of a larger predator, which might then come and eat the first predator. It is a desperate call for help, sacrificing your attacker to a bigger enemy. Flash of light, that calls a bigger monster. The deep ocean is not silent. It is a symphony of groans, clicks, and booms. The cracking of icebergs, the eruption of underwater volcanoes, the shifting of tectonic plates, and the calls of whales all contribute to a constant low-frequency hum. We are only just beginning to listen to this soundscape, to understand the stories it tells about the health of our planet and the lives of the creatures who call the deep home, the slow, deep song of the earth itself. The deep ocean is the last great wilderness on our planet. It is a realm of profound mystery, beauty, and strangeness. It holds the secrets of the origin of life, the history of our climate, and countless species that we have yet to discover. It is a quiet, patient world that reminds us of the vastness of the unknown and the enduring power of life to adapt and survive in the most unlikely of places. It is the dark, beating heart of our living world. The deep, dark water holds you now. The immense, gentle pressure, the soft, slow drift of marine snow, the distant, silent flash of a living light. All of it is a lullaby for the mind. Let the quiet wonders of this hidden world soothe your thoughts and carry you into a deep and peaceful rest. If you enjoyed this quiet journey, I am glad you found your way here. It helps others find this peaceful corner too, one sleepy soul at a time. And now, just breathe, let your eyes close, and let the quiet currents lull your thoughts to sleep. Good night.